You know, when astronauts cry in space, the tears don't actually run down their faces. They just sit there. They pool into this giant watery ball right around their eyes and absolutely refuse to fall, all because gravity isn't there to pull them down.
So let's jump right into this explainer and see how something as totally harmless and automatic as crying suddenly turns into a real physical hazard once you take gravity out of the equation. Because this isn't just some quirky piece of space trivia, right? It's a genuine operational problem that NASA has literally had to study, thoroughly document, and actually train astronauts to handle.
Part 1. The Zero Gravity Tear. How Microgravity Alters Basic Human Biology.
To really grasp what happens to our bodies up in orbit, we've got to look at the sheer mechanical difference in how our eyes manage moisture. Down here on Earth, tears do two things at once. They well up, and gravity immediately pulls them down. Sure, some drain into your nasal passage, which surprisingly still works fine in space, but the visible tear rolling down your cheek, that is entirely dependent on gravity. Now, in microgravity, your tear glands don't magically know you've left the planet. They produce tears exactly like they always do. But instead of falling, surface tension completely takes over.
And by surface tension, I mean that cohesive force that makes liquids stubbornly cling right to the surface of the eye. Because of this tension, the fluid doesn't clear away like your brain inherently expects it to. Instead of a quick wipe, you're left with this slowly growing, watery blob stuck directly over your eyeball. Part 2. An operational space hazard, when biological oddities become critical dangers. This goes from a weird, mildly uncomfortable sensation to a serious operational problem for NASA really fast. The Canadian astronaut Chris Hadfield actually captured this visceral reality perfectly. He described a deeply uncomfortable experience where tears build up into a stinging pool that simply will not drain on its own. I mean, just imagine that for a second. Your body's natural, automatic drainage system completely failing you when you need it most. So the crucial takeaway here is that if enough of this fluid builds up, it literally acts like a thick contact lens made entirely out of water. It completely blurs an astronaut's vision. And when you're inside a spacecraft, blocked vision is not just a minor annoyance, it's a massive hazard. It forces an astronaut to physically stop what they're doing, take their hands off their work, and manually clear their eyes just to stay safe. Which perfectly illustrates why NASA has had to engineer highly specific solutions around this very human problem. They're actively testing specialized wicking materials to manage that fluid buildup during long missions. They've developed specific manual eye-wiping techniques, and they even put astronauts through targeted training for it. They literally have to do this because simply blinking harder isn't going to fix a problem that gravity used to handle for us completely for free.
Part 3. The Floating Tear Threat. Free-floating biological hazards.
But the danger doesn't actually stop at just blurred vision. It builds into this bizarre, escalating hazard. Think about the sequence. Step 1, the tear forms in the gland normally. Step 2, the fluid pools, clinging to the eye and blinding the astronaut. But Step 3 is where things get wild. If the astronaut moves their head suddenly, that massive blob of tears can detach completely from their face. And once it detaches, it becomes a literal, free-floating sphere of bodily fluid just drifting through the spacecraft cabin. Think about the risk there. You've got a roaming ball of water floating dangerously through a highly technical environment until it touches a sensitive surface, shorts out an expensive piece of equipment, or, just floats right into another astronaut. Part 4. The moon face phenomenon, systemic fluid redistribution. Now, crying is really just one localized, kind of poetic symptom of a much larger systemic issue that NASA has studied extensively. Just think about the physics at play. On Earth, gravity is constantly working overtime, pulling fluid downward toward your legs and feet. But up in space, without that constant downward pull, all those bodily fluids aggressively redistribute upward. They move straight toward the head and chest, which profoundly changes how the entire human body operates. This massive upward shift in fluid leads straight to a super common condition they nicknamed moon face. Astronauts actually develop a visibly puffy facial appearance shortly after reaching orbit. It's also exactly why so many of them report a persistent, stuffy nose sensation, which they say feels exactly like having a mild head cold, especially during those first few days in space. It's literally just all that excess fluid sitting up in their heads.
Part 5. Biology Built for Earth. The Physics of Human Evolution.
When we zoom all the way out, these strange symptoms point to a pretty profound realization about the human species. Crying is arguably one of the most universal human experiences there is, right? It's an instinctive emotional response intimately tied to our grief, our joy, and our connection with one another.
Yet, the absolute second we leave the planet, this deeply automatic reflex completely breaks down. It just stops working the way it always has. It's a small, but honestly incredible reminder that our most basic biological reflexes were quietly built entirely around the specific physics of our home planet. Literally, almost everything about being human, right down to our tear ducts, was engineered around the core assumption that Earth's gravity would always be there to move fluids around for us. Step outside that environment even slightly, and the human body just doesn't fully know what to do anymore. So, since stepping just a little bit outside our natural environment leaves our biology this confused, I want to leave you all with a question to think about. We've seen exactly what happens to tears, which totally begs the question, what other everyday human function do you think would break first in space? Drop your guess in the comments below. I read every single one.